Okay, here we go. So I'm going to walk through all these. I'm going to start with the easier ones, and then we'll talk about the more difficult ones. And there's a few examples here, so hopefully that helps. But yeah, I think you guys understand these ones pretty well. We've got NaOH plus H2O. You know that it dissociates in water, and it's one of those first two groups with a hydroxide, so it's very basic. It's a strong base, just because we know that acts as a strong base every single time. So easy, basic. This one we also did in SI, so hopefully it's familiar. But this is how I like to write them, because then you can actually see them, and it's like, I don't know, it just makes more sense. So HNO3 plus NH3 plus H2O. Well, what do we have here? We have a strong acid and we have a weak base. So we have it acidic. Okay, now to this one. The way that I found this to be easiest while I was doing it is I just was like, I'm just going to assume that these dissociate completely and just ignore iron altogether. And the practice problems I've been doing, almost all of them have contained iron. You don't need to know at 3+, why it's Fe3+, but anyway, that's what it is. So that's what it ends up being. But you see how NO3 minus is still in H2O? Yeah, like I said, I'm just ignoring Fe3+. So we've got, I mistyped there. So we got NO3 minus, man, my handwriting's just loving today, plus H2O. So that goes to HNO3, which we know is our strong acid, plus OH minus. Now, don't let that OH minus confuse you, because we have our strong acid. The OH minus is actually going to be accepted by the iron, but like I said, don't care about it. It's just, if you have a problem that looks like this and you have your strong acid and you don't recognize the base, assume it's acidic. So we'll do another one. I explain later in the video in another way that I think clears up the OH confusion a little bit if you're wondering where that goes. So let's walk through the easy ones again. So you got KCN plus H2O goes to KOH plus HCN. Easy money. We know that that's strong base, weak acid. So what is it? Basic. Easy. Now we'll go to FeBr2. So like I said as last time, assume it just dissociates. So you got Fe2 plus Br minus, I guess 2Br minus, but anyway, it doesn't matter. So H2O plus Br. I couldn't get my thing to work here, so it's going to be kind of weird. But yeah, that's going to go to our HBr, which is our strong acid. So once again, you do have that extra OH group, but just don't care about it. It's HBr is your strong acid. So in this case only, like usually you want to know, like if let's say it was KCl, then okay, you want to know where the extra hydrogens are going. But now you've got, I'm not sure why I wrote KNO3. Oh yeah, that's why, because we're on the next one. So yeah, KNO3 plus H2O, KOH, strong base, HNO3, strong acid. We know that's neutral. All right, now we're going to go on I think there's an easier way to explain the FeBr2 and the other one that we did. I don't remember what it was. It was FeNO3. So I'm going to do it down here a little lower, if it'll let me here. Yeah, so you got FeBr2. So same thing, assume it dissociates. This is called doing it in an Arrhenius style, if you guys remember Arrhenius acids. But you got H plus Br minus. Now it makes sense. There's nothing left over. You've got you've got HBr. You got your strong acid. It's acidic. So that's how I like to do it. I felt like that was a little bit of an easier way. But I hope that makes a little bit of sense. Sorry if it's confusing, and let me know if you have any questions.